So for this midterm review, we're going to begin with dimensional analysis, and we're going to start with finding if the average 15-year-old baseball player throws a fastball at 75 miles per hour, what is the speed in feet per second? Well, we want to start by making our roadmap. We know we have miles per hour. Our miles are going to want to turn into feet, and our hours are eventually going to want to turn into seconds. But I cannot go straight from hours to seconds. I have to go from hours to minutes, from minutes to seconds. So I start with what's given, 75 miles over 1 hour per 1 hour. You have to decide what you want to get rid of first. So let's get rid of the miles. Miles is in the numerator, so to get rid of it, you put it in the denominator. And according to our roadmap, miles are going to turn into feet. Miles are larger, so they get the 1. There are 5,280 feet in a mile. Now that I'm done with that, I can see I'm at the end of this roadmap. I want to get rid of the hours. Well, hours are in the denominator, so to get rid of an hour, they go in the numerator. According to my roadmap, my hours turn into minutes. Hours are bigger, and there are 60 minutes in 1 hour. Now I've got to get rid of minutes. They're in the denominator, so to get rid of them, they go in the numerator. And according to my map, minutes turn into seconds. Minutes are bigger, and there are 60 seconds in 1 minute. So now you're just going to take your calculator. You're going to do 75 times 5,280 times 1 times 1. And we're going to divide that by 1 times 1 times 60 times 60. So take a second and plug that into your calculator. So when you type all this in, you should get 110. Remember our units. This needs to be feet per second. For the second one, we have Germany is approximately 4,900 miles away. How far is it in feet from America? Well, we're just trying to turn miles into feet for this problem. So 4,900 miles. It's not per, so I'm just going to use 1 as a placeholder. And we need to get rid of miles. They're in the numerator, so they move to the denominator. And they're turning into feet. Well, miles are bigger, so you put a 1 there. And there are 5,280 feet in a mile. So in your calculator, you're simply going to type in 4,900 times 5,280. And you get the answer to be 25,872,000 feet. So we're going to start simplifying expressions. This is moving into order of operations using polynomials. So this is where you want to take out some highlighters. And remember, we are only combining like terms here. So I have an m squared that can only be combined with m squared. I don't have any more, so I move on. I have a negative 8m, and that is going to be combined with 8m. I have a positive 2, and that positive 2 is also going to be combined with the other constant of positive 2. Then I'm also left with a 8m to the 4th. So remember standard form. Standard form is where we put these things in order from highest exponent to the lowest. So if I were to first go through and just make a list, nothing is combined with 7m squared. I have negative 8m minus 8m. So if we do a keep change, it's like negative 8 plus negative 8, which gives me negative 16m. 2 minus 2, which is going to cancel each other out. And then I have a 0 minus 8m to the 4th, which gives me negative 8m to the 4th. So now I just want to put this in order from highest exponent to lowest, where I get negative 8m to the 4th plus 7m squared minus 16m, which is going to give me answer choice C. Same thing on number 4 here. We're combining like terms. So I have an x squared and I have a 6x squared that are going to combine. I have a 5x to the 3rd. That has nothing to combine with. I have a 6x to the fourth, which is going to combine with x to the fourth. And then finally, I'm left with negative 2x. So we just want to go through and combine things that are alike here where we can. So 1x squared plus 6x squared gives us 7x squared. 5x to the third has nobody to pair up with, so we just rewrite it. 6x to the fourth plus 1x to the fourth gives me 7x to the fourth. And then 0 plus negative 2x. So remember, what we're going to do here is put this in standard form. So highest exponent to the lowest. So 7x to the fourth plus 5x to the third plus 7x squared minus 2x, which is going to give me answer choice A. We're going to do the exact same thing here, except for I just don't have answer choices, so I still want to combine like terms. Positive 8 has no negative 8 to combine with. N to the third has 3n to the third. Negative 6n squared has positive 6n squared. And then finally we have negative 2n. So as we go through here, 8 plus negative 8 goes away. That's 0. 1n to the third plus 3n to the third gives me 4n to the third. Negative 6n squared plus 6n squared goes away. That becomes 0. And then I have 0 plus negative 2n, which is negative 2n. Check to make sure this is in standard form, which it is, highest exponent to the lowest. So that is our final answer. For number 6, same deal. I'm combining like terms, so I have 6n to the fourth, which is going to combine with positive n to the fourth. Negative n squared, which has nothing to combine with. Positive 6, which is going to combine with 1. And then we have 3n, which will combine with 4n. Watch your sign here as you're getting ready to solve. Remember that we are subtracting, so 6n to the fourth minus 1n to the fourth is going to give us 5n to the fourth. There's nothing to combine the negative n squared with, so minus n squared. 6 minus 1 will give me a positive 5. And then we have 3n minus 4n, which gives me negative 1n. I cannot leave this as my answer because it's not in standard form. So I want to put these in order from highest exponent down to the lowest, which would look like this. Now we're moving on. Remember, to find the product means we're multiplying. You have two options when multiplying. Those two options are to use the distributive method and the box method. I'm going to use a variety of these as we move through. I'm going to distribute this first one. So 5 times 6 gives me 30. I have 4 a's that's combining with 1a, which is going to give me a to the fifth. Then 5a to the fourth times negative 1 is going to give me negative 5a to the fourth. So answer choice D. We'll box this next one. Now I could distribute. I'll show you how to do that again later on number 11. But if I'm going to use the box method, I take the first polynomial, 7n plus 5. I'm going to put it across the top. And I take n minus 8 and I put it down the side. Now we just want to multiply. N times 7n gives me 7n squared. N times 5 is positive 5n. We have negative 8 times 7, which is going to give us negative 56n. And then negative 8 times 5, which gives us negative 40. Remember, anytime we use the box method, when we combine like terms, it's the peanut that's in the middle here. So I'll be left with 7n squared minus 51n minus 40. So answer choice C. We're going to come back and distribute again. So 5a squared times 6a is going to give me 30a to the third, because I had 2 a's and I'm combining another a with it. Then 5a squared plus 6, or times positive 6, is going to give me positive 30a squared. I look, this is already in standard form, which is nice, and I do not have to simplify it because it's already where it needs to be. For number 10, we're going to go back to our box method here. This time I'm going to take the first one and put it across the side. It really doesn't matter where you choose to put these. My second polynomial I'm going to put across the top. Remember, you are taking the sign with you in each box. We're simply going to multiply. So negative 5n times 6n squared is going to give me negative 30n to the third. Negative 5n times negative 8n gives me 40n squared. Negative 5n times negative 6 gives us positive 30n. Negative 3 times 6n squared is negative 18n squared. Negative 3 times negative 8 gives me positive 24n. Negative 3 times negative 6 gives me positive 18. Remember, we want a peanut here. Find our like terms. Those are going to be on the diagonal of one another. So I have two sets of like terms. For my final answer to be negative 30n to the third, that's going to be a positive 22n squared, positive 54n plus 18. Remember, I know that I'm going to add each of these because I can see inside the small plus signs. Now, if you want to distribute these, I would do 5b times 6b, which would give me 30b squared. I'd do 5b times negative 6, which would give me negative 30b. 4 times 6b, positive 24b. And 4 times negative 6, which is going to give me negative 24. I want to make sure that I combine my like terms. So for my final answer, I'll have 30b squared minus 6b minus 24. For number 12, where it says find the perimeter, we'll remember that if I'm finding the perimeter, that is meaning add all sides, which just means I'm going to combine like terms. So I have 2x, it's going to be combined with 5x, which is going to be combined with 4x. 2 plus 5 is 7. 7 plus 4 is 11x. Then I'm going to combine my constants. So I have negative 1 plus 5, which is going to give us a positive 4. So the final answer for this one will be 11x plus 4. If I'm being told to find the area, the definition of area is length times width. Well, my length here is 3x plus 2, while my width is x plus 4. So you have options whether or not you want to use the box method or distribute. I'll distribute this one. 3x times x gives me 3x squared. 3x times 4 gives me 12x. 2 times x gives me 2x. And 2 times 4 gives me 8. You want to combine like terms. So I'll be left with 3x squared plus 14x plus 8. Okay, as we transition to naming polynomials by degree and number of terms, we need to remember that one term is called a monomial, 2 terms is called a binomial, 3 terms is called a polynomial, and 4 or more terms is called a polynomial. 3 terms is a trinomial. I'm not sure if I said that correctly. For our degree, a degree of 0, meaning there is no variable, is going to be called a constant. A degree of 1 will be called linear. A degree of 2 is quadratic. So if we look at number 14, there's only one term, which I know means it has to be a monomial. And this is a constant because there is no variable. For number 15, we know that there are 2 terms. So that means it is a binomial. I'm left with quadratic or quintic. And because the highest exponent is squared, I know that that is a quadratic binomial. We're now going to transition into sequences, arithmetic and geometric sequences. So for an arithmetic sequence, remember we are going to add to get to the next term. For a geometric sequence, we are going to multiply. The thing here, when we add, it is a common difference, meaning I'm adding the same number every single time. And if I'm multiplying, it's a common ratio, meaning I multiply by the same number every single time. So if I can look at number 16, I automatically see that my signs are rotating. 3, negative 12, 48, negative 192. So I'm going to go ahead and check to see if it's geometric. And in this case it is, because every time I am multiplying by a negative 4. For 17, I can notice that my numbers are increasing. Negative 26, negative 20, negative 14. I'm actually adding 6 every time, which is going to make this arithmetic. When I look at number 18, we often think that just because there's fractions and whole numbers that it's going to be neither. But remember, you need to test this. We do negative 7 halves minus negative 5. And if you do that, you get 3 halves. Then you want to test negative 2 minus negative 7 halves, where you get 3 halves. Negative 1 half minus negative 2. And because I'm subtracting, that's the inverse of adding. So I know that this is going to be an arithmetic sequence with a common ratio of 3 halves. As I look at number 19, 3, 5, 8, 12, 17. Well, if I'm looking from 3 to 5, I'm adding 2. 5 to 8, I'm adding 3. 8 to 12, I'm adding 4. 12 to 17, I'm adding 5. So this one is going to be neither. I am adding, but I'm not adding by the same number every single time. As we move on to finding the first terms in the sequence, well, right away I see that my first term is 19, so it either has to be A or B. And then I'm going to add 8. So 19 plus 8 is going to give me 27, plus 8 gives me 35, plus 8 gives me 43. So I know number 20 has to be letter A. For 21, my first term is negative 2.5, so I know it either has to be A or D. I'm going to multiply this every time by a negative 2. Well, I right away can go ahead and check and make sure that my signs alternate because I'm multiplying by a negative 2, so I need a negative, positive, negative, positive, negative, positive, negative, positive. So I just want to take these numbers now and do negative 2.5 times negative 2, and that's where I get a positive 5. So this one is also going to be A. Remember that you do not have to memorize the formulas for explicit and recursive arithmetic or explicit and recursive geometric. Those are going to be provided for you on the formula sheet. So if I'm looking at an arithmetic explicit formula, I'm looking at a sub n equals a sub 1 plus the common difference times n minus 1. If I'm going to use a geometric explicit formula, that is going to be a sub n equals a1 times r to the n minus 1 power. So remember, a1 is simply going to represent the first term. If I'm looking for a common difference, that'll be d when I'm using arithmetic, or common ratio, r, when I'm multiplying. So the first thing we have to do is identify, am I adding or am I multiplying to get to the next term? So for number 22, I can see that I'm actually adding a negative 10. So my common difference in this case is going to be negative 10. My first term was 33, so I'm going to subtract 10 times n minus 1. Well, I can notice that these are in closed form, so I'm going to have to distribute the negative 10, where I get 33 minus 10n, and then negative 10 times negative 1 gives me positive 10. So I'm actually looking for the formula negative 10n plus 43, which is going to give me letter D. For 23, I can see my signs are alternating, so I know that I'm multiplying. So for my first term, I've got negative 1.25. Right away, I can see that there's only going to be one answer here, that's going to be D. But when I multiply all these things, I'm multiplying by a negative 4. Okay, so now we want to match the correct sequence to the formula. I've got 2, 12, 72, 432. I know I'm not adding here, so I know that I am going to multiply, and this is going to be multiplied by 6. So I'm either looking at C or D. Well, I know this one has to be C because I am multiplying by 6, not dividing by 6. For number 25, 2, negative 4, negative 10, negative 16. I am adding here, and I'm actually adding a negative 6. So if I add a negative 6, I know that's going to be either A or B. This is a positive 6. So I'm starting here with my first term of 2. So 25 is A. For 26, I know that I'm going to be multiplying, which means there's only one geometric left over, and I'm multiplying by 1/6, or you could say that I'm dividing by 6 if you needed to. Then finally, I'm adding 6 every time, which means that this is going to be B. When I look at 28 and 29, I'm still going to create these formulas. I first have to determine what's happening. So for 28, I am actually adding 4 every time, which means it needs to be the arithmetic explicit formula. The first term is 4. My common difference here is 4. And I'm finding the n minus 1 value. Well, if they're asking me to find 10, when I plug this in, 4 plus 4 times 10 minus 1, so that's 9 times 4 is 36. That gives me the value of 40. We're looking at 29, 128 to 64 to 32 to 16. I'm actually cutting each of these things in half, so I'm multiplying by 1/2 or 0.5. My first term is 128. Multiply it by 1/2 to the n minus 1 power. So if I want to plug this in for the 10th term, 128 times 1/2 to the 10 minus 1. That is going to give me an answer of 1/4. If you want to put an answer in a decimal form here, you can. That would be 0.25. Okay, still matching our sequences. So as I look here, I can see that this is recursive right away, and I just have to determine if what is there is adding or if it is multiplying. Well, I see subtract 2, which means that's like adding a negative. So this is going to be arithmetic recursive. For 31, I see that it's multiplying and it is in the explicit formula. So that will be geometric and explicit. I see it's recursive, and I also see that I'm multiplying. So this is going to be C. And then this is my open explicit arithmetic sequence. I see the plus sign, so I know that it has to be B here. For this next section of the review, we're going to be looking at scenarios whether they're discrete or continuous. Remember, continuous is going to be where every value in the domain can be covered, so halves, 0.75s, all of those things. Where discrete is you cannot have half sizes. So the distance from your house to Atlanta as you drive, distance is always going to be continuous because I can go 0.1 miles or 0.99 miles or 7.99 miles. Your shoe size as you grow is going to be discrete. Now, even though your shoe size can be a half, you can't wear a 3.75, so therefore that is discrete. Height of a tree, continuous, because we can grow at any point. And then the amount of pencils in your backpack are going to be discrete. You're not going to have 2.5 pencils. Our next section is looking at linear or exponential functions. So remember, for linear functions, we're going to add to get to the next term, even if it's adding a negative. For exponential functions, we're going to multiply. And if it's getting smaller, we're going to multiply by a fraction. So 10, 20, 30, 40, 50, I'm adding 10 every time, which means that this is going to be a linear function. Sally's cookies, she's baked 3 dozen the first day. She's going to bake 4 times that amount, and then 4 times that amount again. 4 times right away tells me it's going to be exponential. The amount of antibiotic your body decreases by 15%. Well, anytime I see a percent, I know that that is going to be a multiplication problem, so it's exponential. The amount of money you earn at your job per hour. The word per means I'm doing it every time. That's going to be linear. For our graphs, this is where you're going to want to go to Desmos, and I'm going to let you do this on your own. The only thing that I am going to advise you for is remember where your asymptotes are on each of these. So because I don't add or subtract anything, my asymptote is at 0 for this problem, which means my graph should not cross or touch x equals 0, or I'm sorry, y equals 0. As I look at the next one, 44, I have an asymptote of positive 2, which will be here, which means that my graph should not touch nor cross negative 2. For 45, my asymptote is at negative 4. Okay. And so my graph should not touch or cross negative 4. Again, this is where you need to go into Desmos, type these things into the graphing calculator, and create your chart. All right, for these next parts, you're going to be writing the equation of the linear functions. For 46, we can see that's a vertical line, which means it's going to start with x equals, and then we just say what x equals, which is 2. For 47, our y-intercept is a positive 3, so I'm going to go ahead and put plus 3. And then for our slope, we went down 1 and then to the right 3. So because I went down 1, it's negative 1, and I went to the right 3, so positive 3. Just don't forget to put the x there. For 48, we see that my y-intercept is a positive 2. Okay, and I went up 1 and to the right 4. So up 1, positive 1 to the right 4, positive 4. Get that variable in there for x. For 49, my y-intercept is positive 4. And then I'm going to go down 1, 2 to the right 3. Okay, so I'm starting at my y-intercept. I'm going down 1, 2, 3, and I'm going to the right 1, 2. So because I went down 3, that's negative 3, and I went to the right 2, that's a positive 2. So I throw the x in there to make sure I get my full equation. Now we're getting into the exponential interest word problems. So here we have $25,000 that we're investing into an account that compounds semi-annually. The account has an interest rate of 4.5%. And what would our value be after 35 years? We want to remember the compound interest formula is P times 1 plus R over N to the N times T power. So we just want to fill in the values of where we can here. My principal is $25,000. The 1 plus never changes. My rate I have to turn into a decimal. So that's going to be 0.045. Compounded semi-annually means twice a year. And so then I'm going to do 2 times 35 as the exponent. Once you have that set up, all you're going to have to do is plug that into the calculator. And we get that the account will have $118,678.53. Again, we know to use the compound interest because we see that compounded semi-annually. Okay, the other word problem we have here, you loan your friend $1,000 to go on a trip to whatever land, and he agrees to pay you 8% for 3 years. So this is going to be a simple interest problem. And that is going to be P plus P times RT. So that would be $1,000 plus 1,000 times 0.08